Hi, welcome to clickmyproject.com. Requested title is a combined mining-based framework for predicting telecommunications customer payment behaviors. Let's move on abstract. Most existing data mining algorithms apply data-driven data mining technologies. The major disadvantage of this method is that expert analysis is required before the derived information can be used. In this paper, we thus adopt a domain-driven data mining strategy and utilize association rules, clustering, and decision trees to analyze the data from fixed-line uses for establishing a late payment prediction system, namely the combined mining-based customer payment behavior prediction system. The combined mining-based customer payment behavior prediction system could indicate the potential users who may not pay the fees on time. In the implementation of the proposed system, first association rules were used to analyze the customer payment behavior, and results of analysis were used to generate derivative attributes. Next, the clustering algorithm was used for customer segmentation. The cluster of customers who paid their bills was not found and were deleted to reduce the data imbalances. Finally, a decision tree was utilized to predict and analyze the rest of the data using derivative attributes and the attributes provided by the telecom providers. The evaluation results, the average accuracy of prediction model was 78.53% under the average recall of 88.13% and an average gain of 11.2% after a 6-month validation. Since the prediction accuracy of the existing method used by telecom providers was 65.16%, the prediction accuracy of the proposed model was 13% greater. In other words, the results indicate that the prediction model is effective and is better than that existing approach used in the telecom providers. Flow of the project. First, we are extracting the dataset into a database. We are using the datasets such as CDR dataset, payment dataset, and month-wise dataset. In CDR dataset, we are mentioning the status of the users, and payment dataset, we are mentioning the late payment of the users, and in month-wise dataset, we are mentioning the third and fourth month and 6th month of the dataset, and we are applying the clustering for the inserted records. Based on the applying the cluster, we are getting the clustered result, and after getting the result, we are applying the a priori algorithm to the inserted records. In a priori algorithm, we are applying the association rules, and we are getting the frequent item and maximal item of the inserted records and payment status. And based on this association rule, we are getting the frequent items and we are getting the support and confidence of the transaction items. And next, we are generating the decision tree for the payment users and not payment users. And based on the decision tree, we are generating the decision rules for finding the payment users. And based on this rule, we are getting the prediction accuracy. For getting the prediction accuracy, we have to calculate the accuracy and recall and accuracy of provider. And thus we are getting the accuracy based on payment users and non-payment users. That is, we are getting the A and B of status of the users. And based on this, we are get the recall value by the payment status. Finally, we are getting the prediction accuracy, and based on this, we are next module is payment. In payment module, the user will be reduce the payment from the name balance. Next, execution of project. Let's start execution. This is the home page of the project. Here you can load and view the original dataset here. Further, how to load the dataset. So I am loading the payment dataset here, and this is the content of the dataset. And next, we are importing the dataset into a database. So first we have to load the dataset here. So I am loading the payment dataset and importing the dataset into a database, and we can view the inserted records. And these are the inserted records of the dataset. And the dataset content is we can view the customer ID and bill month and payment status of the customers. And next we are applying the a priori algorithm. In a priori algorithm, we can add the item into a item set and delete the item from the item set, and add the transaction item set from the transactions, and edit the transaction and then edit the transaction, and we can delete the transfer items here, and we can clear all the transaction. First we can add the transaction by clicking the item set, and I'm selecting the item and adding the transaction into a transaction set, and we can transfer any number of items. So we have to find the minimum support and minimum confidence of the transfer items, and for that we have to provide the minimum support and minimum confidence randomly. And I'm solving the algorithm based on the support and confidence, and these are the items, and these are the support of the selected items, there is transferred items, and these are the maximal items which we transferred, and these are the closed items. And based on this supports and items set, we are getting the confidence of the transferred items. And next is association rule result. Based on this algorithm, we are getting the association rule result. So by clicking association rule mining, we can get the association rule result here. From here we can get the who are all paid, that is it is 02 mentioned that customers are paid the fee. So next here go to clustering. Here we are forming the cluster from selecting the number of clusters. I'm selecting 6, so we can form the clusters based on the selected count. And let's start the cluster, and by clicking run button, cluster will be executed. And these are the colors mentioning the status of the payments. And next is cluster result. Here we can view the result of the cluster. After that we can get the not payment users here, and next and customer ID, bill month, and not payment users of the status. And next is decision tree. In decision tree we can form the trees based on the status. First we have to fill the rule here, so we can get the status and not payment users. This is the payment status of the users. 0101 mentioned that not payment users, and bank details of the non-payment users are displayed here. And we can by selecting the mouse button, we can select the coordinates points to draw the tree, and by selecting the checkbox, we can draw the decision tree into a panel. And next one is decision rule. In decision rule, we are forming the decision rule for getting the not payment users. And for that we have to load the month dataset here. So I'm loading the dataset, that is month dataset here, and I am importing the dataset into a database, record inserted, and these are the content of the month dataset. Here we can view the payment status and month of the bill, and maximum amount, and customer ID and status of the customer, and type of the payment of here. And this is the total payment and status amount. And first we are getting the not payment of third month and fourth month. If the user is not paid in third month and fourth month, he would not paid in sixth month. Who we are updating the status as 1 into a sixth month, who are all not paid into a third and fourth month. So we are getting the third and fourth month status. And when I'm clicking this customer ID, I can update the status of customer ID as 17 to 1. So 1 is mentioned that not paid. So I am updating the database, and we can view the updated data here. So when I am moving to the 17, the customer ID, it is updated that 1. So it is updated. And next we are predicting the accuracy of the not payment users. So first we are predicting the prediction accuracy, and A is mentioned that number of correctly predicted late payment user, and B is predicted number of late payment user. So we are dividing the number of late payment users and predicted number of late payment users. We are getting the result as 0.75, and we are getting the recall value as the number of correctly predicted payment users divided by actual late payment users. So next the accuracy of providers. For accuracy of providers, we are getting the actual late payment users divided by total actual number of users. So we are getting the result as 0.6. And finally, we are making the payment to the not payment users. So we are getting the user details as not payment users and late payment. These are the user details, and from this we are getting the late payment users, and late payment users as displayed here. So I'm selecting the late payment users here and entering the pending amount for the late payment users. When I'm clicking the confirm payment, I can reduce the pending amount from the main balance of the selected user.